DockerCon 2016 at the Twistlock booth. Can you tell us a little bit about the company and how you fit into the Docker ecosystem?
Sure. Hi, my name is Chenxi Wang. I'm the Chief Strategy Officer for Twistlock. We are a container security company. We protect Docker containers from inception. The minute Docker images are composed, we protect the image, we look for vulnerabilities, we try to get the image as robust, as clean as possible before it gets to the production host. And we protect production systems on the host, the production containers. We protect it from active threats as well as anomaly detection. So we are a Docker partner. We are in the Docker ecosystem. We work with lots of enterprise clients, enterprise customers. This DockerCon has been amazing. We've seen an amazing amount of traffic, an amazing amount of interest. A lot of enterprise customers, enterprise accounts are deploying Dockers, either starting to deploy or already rolling out. And we saw this as an amazing trend starting last year, and this year really started to take off. And we're very happy to be one of the ecosystem partners that is enabling this trend. Our solutions enable enterprise customers deploying containers and propel their innovation without worrying about security and compliance.
Great, and could we get a demo of the product?
Yes, absolutely. We'll take you over here to get a demo.
Awesome.
Hi, my name is Michael Withrow. I'm the Director of Architecture here at Twistlock. So what I'm going to do is I'm going to walk you guys through a high level of what we do from a product perspective. So what we're looking at here is actually our UI for Twistlock. This is just a container running a Node.js console. As you can see, the starting point, really what we have here is this is just a high-level executive dashboard. We have a tree map here, kind of breaks down, what's the state of my Docker ecosystem that I have it deployed in my enterprise, right? How many defenders I have deployed, what are my violations that I'm seeing across my topology, those kind of things like that. I can bore down into here. Here's my Kubernetes environment. I can see a little bit more richer information around what's going on from a security perspective across those images. I can go into here. I can actually browse down, get a little deeper, and then I can actually browse down, and that's going to take me all the way back. And now I'm actually looking at the vulnerability data that exists across that particular container that I'm looking at, right? See all the vulnerabilities that exist from a CIS perspective across that particular image, right? So as you look at it, right, so from a core product perspective, the starting point as we get around it, right, is, hey, look, now we're looking at a high level, right, but what do we really bring to the table? So obviously from a product perspective, we started the CI pipeline process. So maybe you're using Jenkins as an example, right? So we integrate directly in that CI pipeline process. Here's a Jenkins build, and the output from that build is really going, hey, look, this developer built this image and it has 8 vulnerabilities in it, right? And that's all going to correlate back to that particular, the console from that particular perspective. So staying on the trend of vulnerability, right? So hey, look, a developer's building an image. We're going to inject in the CI pipeline process. Then he's going to basically post it into a registry. We're going to basically peer into that registry, give you the state of that image while it lives in the registry. You can see here, hey, look, here's a Docker whale image, right? It's got 108 vulnerabilities. I can peer into that and get a little bit richer information down here across those 108 vulnerabilities that exist in that particular image, right? And actually peer out from that particular perspective as well. So what we're looking at from an entire lifecycle perspective. So now we're looking at the image itself, right, as it pertains to a host. You see the relationship between the image and the host itself, and all the way down to the vulnerability state of that image as it exists from that particular snapshot that we're doing that as well. Then we take it a step further, because now you're going to take that image and you're going to attach it to a container. We're looking at that relationship that exists there, right? Building out that information, you're seeing now the commands that are being run, you're seeing the image ID, the container that it's a part of, and the state of that particular container, right? Same thing, you can browse down into that and get a little bit deeper from that particular point as well. As we walk down to it, so how we do enforcement of all of this and how we do it is essentially what we're doing is starting with a series of scans. So on build, essentially what we're doing is trying to break that image down, build a bill of materials of that image, right? And that's what we're doing. So now that we have that bill of materials, that's where we're starting to get that signature data, and the vulnerabilities that exist across those signatures is what we're kind of building out. Now we get into like the enforcement, right? Because now what we do is we have this defender here which is just another container which you deploy in all your Docker daemons, right, from that particular regard. So what this does is this basically enforces the state that you want to maintain across your environment, whether it's from a vulnerability perspective, whether it's from an access control perspective, whether it's from a compliance perspective, and lastly, most importantly, whether it's from a runtime perspective. Because like I said, we start from the vulnerability perspective doing all this work, but essentially what we're doing is conducting a series of scans, right? That first one being that static image analysis, but we're also looking at the system calls that this image makes, the processor state, the file system state, the networking state, and then as you're deploying those containers into runtime, now what we do is we whitelist that capability out. So now, if anything happens on that container that is outside what was built, essentially what we're doing is alerting on that capability because it is considered an anomaly at that particular point. So now as you look at it from a container perspective, essentially here we have the state of that topology, right? So hey look, here's the system calls that I see across that particular ecosystem, right? So I'm going to see this is the container that the infraction happened on, this is what actually happened, there's a chdir that happened on that particular container, and this is the date that actually transpired. As I go through processes, it's the same kind of feel in that particular regard. Here's the container that happened, here's the process that was launched, and the date that transpired, right? And then as we go across the networks, it's the same kind of thing. We're seeing the container, the communication path that happened. Obviously, someone tried to establish a connection to port 443 from that particular perspective. So now you're getting into really, how do we do this? And that's when that whitelist becomes very, very important, right? So essentially what we're doing, as an example, you deployed an Nginx container, right? Or an Nginx image, I should say. With that, you expose port 443 as an example, right, in that particular regard. So now we have these series of sensors. We know what the file system topology of that image is, the network, the process, and the system calls. So now that you have it deployed, we know that 443 is exposed, in an example, right? So now, as an example in here, hey look, someone just tried to establish a connection to port 453, and that's why we lit up in that regard, right? On the process side, we know that the only process supposed to run in this container is Nginx, but someone just kicked off a wget, right? As an example, so now we flag that, alert on that capability, right? Same thing from the file system perspective. Hey look, we know we have the hash values for all the malware that exists from an industry perspective. We saw here that someone tried to write down a known malware down to the file system for that and alerted on that capability as well from this particular perspective, right? And same thing across the system calls. We've recorded the system calls that this Nginx image makes. If like say a buffer overflow, someone tries to do a buffer overflow against your Nginx image, we would see that in the system calls because we've deemed that as anomalous in that particular regard. So as you look at it, right, from a console perspective, essentially what we're doing is here you define what you want to protect, right? Then you get down here and now you're starting to build out how I want to protect those things, right? So here's access control. So here I have policy enforcement. I can go through and say, hey look, I want to allow or deny these API calls for these users across these containers, images, or hosts, right? So I can get very specific and say, hey look, I'm going to allow this user to basically talk to this container only, right, as an example. And I can build that out and restrict, and so now the only thing that person can do in that group is do these API calls on that particular container. And then most importantly, we have an audit trail off the back end of that.
And where can they go if they want to find out more information about Twistlock?
So you can go to basically twistlock.com and you can go there and then see we have a high level view, white papers, and then we also have access to a developer edition. You go there and request a developer edition and kick the tires yourself.
Awesome.